I'm real excited about today's episode, Dry Fly Dubbing. Designing and making your own dubbing can be an art form in and of itself and a great part of fly tying. When you sit down to tie a dry fly and you're selecting dubbing, you look at color and you look at sparkle, which are two straightforward characteristics that you can implement. Things like float time, texture of the fly, and lifelike movement of your fly due to the dubbing require a little bit more information to implement those. We're going to start with the aquatic animals. We use those for dry fly fibers because the land animal furs tend to sink really quickly and absorb water. We're also going to look at the kapok tree and one synthetic, which is polyurethane, also known as fine and dry. The texture of your fly is determined by the guard hairs, and we're going to look into those. Diameter of your dubbing body is given to us by the down fibers. Water resistance, specific gravity, and the ability of the fibers to bond together give us our floatability. And I developed a sink test to see how long our dubbings float on their own. To understand what keeps our flies afloat, we need to understand specific gravity. Specific gravity is simply the weight of a material with respect to water, with water being 1. Anything less than 1 will float, anything more than 1 will sink. Looking at the numbers, our animal fibers and our polypropylene will add very little to the buoyancy of the fly. Kapok fibers add more buoyancy, but are not enough to overcome the weight of the hook. The air trapped between the fibers with a specific gravity of 0.0013 is what keeps our flies afloat. Now, although the kapok fibers will lift 30 times its weight, there isn't enough material there to overcome the weight of the hook. Air will lift almost 800 times its weight, and the air trapped between the fibers is what floats our fly. Once this air is replaced, our fly will sink, regardless of the materials that we're using. To understand what will impact our texture of our fly, we need to look at the fiber size. In most cases, our guard hairs have a diameter of around 100 microns. If we look at a white blood cell, which is at 25 microns, our dry fly dubbings, the down, is very, very small, anywhere from 12 to 15. It is this small diameter fiber that gives us the size of our dubbed body. One other item to look at is hair density, and as a reference, the hairs on our head are 300 hairs per square centimeter. The best overall dry fly dubbing out there is from the Beaver. The Beaver has these down hairs with a diameter of 14 microns that can make a nice, tight, dubbed body. You can even make a thinner body if you trim the 12 millimeter long down furs to smaller sizes. For varying amounts of texture, you have these guard hairs that are almost 30 millimeters long, but they have this thickness of 112 microns, just huge in the fiber world. By cutting the guard hairs shorter of different lengths and mixing with the down fibers, you can get any textured body you want, or you can remove them altogether. The hair density of the Beaver is kind of typical, but the float time is almost 2 minutes, and that's because most of our dry fly furs tend to mat and bond together to prevent water from soaking in. What makes Beaver also really nice is that commercially you can get it into some colors. You can buy it on the patch or in the pelt, and then you can get blended colors as well. The best floating dry fly dubbing is from the animal Otter. Otter's down hair fibers are 12.5 millimeters, which is at the lower end. Thus we can have a very nice tight body. The down fibers are 11 millimeters long, and if you trim them even shorter, you can get a tighter body. For adding texture, you have these nice long guard hairs that are twice as long as down hairs, but the thickness of them is 130 microns, which is really huge. So by varying the length and the concentration and mixing it with the down fibers, you can get any texture that you want, or you can remove them altogether. Recall that the human hair has 300 hairs per square centimeter. But if you look at the otter, It has over 140,000 hairs per square centimeter, just huge. This concentration and the ability of the fibers to mat together gets it a float time of over 8 hours. I have left it in overnight. Unfortunately for Otter, there's no commercial colors available, so you're limited on the color of flies that you can tie. Muskrat is the favorite fly for the Adams. It has not found a lot of favor in tying other flies. The down hairs are very small, at 13.4 micrometers, so it'll make a tight body. As you can see here, this is one of the smallest ones at 1 millimeter. Again, probably why it's used for the Adams on flies all the way down to 22s. You can get some lifelike movement if you include the guard hairs. They're fairly thin at 80 microns. The length is 32 millimeters, and you can trim them to different lengths to get you the desired texture you're looking for. Float time is about 4 minutes. Unfortunately, you can't get this dubbing in any colors except for the natural shades. The next natural animal dry fly dubbing is nutria. Nutria is probably the least popular of our animal dry fly dubbings. However, it is the least expensive, as nutria has been destroying the marshlands and there's bounties for the nutria. So pelts are readily available and fairly inexpensive. The unique thing about the nutria is that it has two sets of guard hairs. It has ones that are 15 millimeters long, ones that are 30 millimeters long. They both have the same size of 74 microns, so mixing these together can get you almost any texture and lively looking dubbing that you want. The down hairs are at the upper end of our animals at 16 micrometers, and it actually ties a very large body. It is difficult though to remove the guard hairs, and there's no commercial colors available, so you're limited to shades of chocolate and gray. It does have a great float time of 15 minutes. This fiber is from the kapok tree. It is the only fiber that doesn't impact wildlife or pollute the environment with polyurethane nylons. Here's a snapshot from the packaging, and they're claiming it is high floating and supports 30 times its weight. That is true, and I do like the high floating part of it because the specific gravity is 0.05, which is fairly light, and it is perfect for dry flies. The fibers are not finer than superfine. I measured the fiber size to be 26 micrometers, and the fiber length is 1.8 centimeters, which is really long if you want a tight-bodied fly. As you can see here on our 1 extra fine hook, we have 1.5 millimeters. There are lots of colors in the lighter shades, as seen here. Dubbing was fairly easy, and the float time is about 10 seconds. The synthetic dubbing we are going to look at is a polypropylene, better known as superfine. The package says the dubbing is permanently waterproof, and that is true. Each individual fiber will not absorb any water. It is hydrophobic. However, the dubbing around the hook does not present any barrier for the water to come in and replace the air, so it will sink almost immediately. The fibers are very small, but they do not make a very small body around the fly, and that because the fibers are fairly long. They need to be cut shorter to make a finer body, especially if you're going to go down to a size 22 as they advertise here. You can get it in lots of colors, and it is very popular, but you need to understand it doesn't float very well. I want to do a demonstration about capillary action, on how it's really our enemy of the dubbing. We have our beautiful lake, beautiful blue lake. We have our hook, and we painstakingly put on a gorgeous piece of dubbing, and we cast it into the water. Now initially it's going to float, but capillary action is going to cause our little fly to get waterlogged really quickly. dependent on the fibers is in it. And this is what dooms us as dry fly dubbing and being able to float.